Ever tried to find a specific research paper in a field that's growing faster than you can keep up with? Imagine trying to organize a library where new books are published every minute, and the categories themselves are constantly changing. That's the reality for scientists today. Traditional taxonomies, those structured ways to classify knowledge, are like old family trees. They take forever to build, and by the time they're done, the branches have already grown in new directions. Meanwhile, automated tools either rely on outdated data or miss the bigger picture. But what if we could create a living taxonomy that evolves with the research itself? That's where TaxoAdapt comes in. This framework uses large language models, or LLMs, to build taxonomies that adapt across multiple dimensions, like methods, tasks, and evaluation metrics, instead of just one. Think of it as a tree that grows new branches and roots as the forest changes. Here's how it works. TaxoAdapt doesn't just look at keywords in papers. It analyzes how each paper contributes to different areas, like whether it introduces a new method, a dataset, or a benchmark. Then it uses hierarchical classification to decide where to expand the taxonomy. If a topic has lots of papers, like reinforcement learning, it digs deeper. If there's a gap, like decode-only models, it branches out. And here's the kicker, TaxoAdapt doesn't just guess. It uses the corpus itself as a guide. By focusing on document-level reasoning, it ensures the taxonomy stays relevant to the specific research area. This approach is 26% more precise and 50% more coherent than existing methods, according to their tests. So the big question, can big language models replace traditional taxonomies? Think of a taxonomy like a library's catalog system, those categories that help us find books, articles, or research. But this study introduces something new, TaxoAdapt, a method that uses a smaller open-source model. Surprisingly, it outperforms expectations, scoring high in most tests. But here's the twist, its coverage is lower. Why? Because TaxoAdapt creates broader, coarser categories, like grouping all healthcare topics under one umbrella instead of diving into specifics. This trade-off means it's less detailed in some areas, but still shines in specialized fields. Let's look at real-world examples. The study compares taxonomies from EMNLP 22 and EMNLP 24, two major NLP conferences. In 2022, the categories were broad, healthcare, e-commerce, legal. But by 2024, they've exploded into hyper-specific areas: medical record management, clinical decision support, even patient engagement. This shows how LLMs are helping researchers explore deeper and wider, uncovering niche applications. A big trend: multimodal research is booming. These models now handle text, images, and more, leading to innovations like multimodal NLP in healthcare or security and privacy. But the biggest new node in 2024: automated fact-checking. Why? Because as LLMs grow more powerful, their tendency to hallucinate, make up facts, has become a major concern. Researchers are now racing to build tools that verify information, a direct response to this challenge. The study also reveals how TaxoAdapt adapts. By analyzing trends in paper titles and keywords, it captures how fields evolve. Whether it's legal case retrieval or mental health support, the model tracks where the research is heading. So what does this mean? LLMs aren't just replacing taxonomies, they're transforming them. They help us spot emerging trends, like automated fact-checking, while still needing human oversight for precision. The future of knowledge organization isn't just about scale. It's about balancing breadth and depth in a world where AI is changing faster than ever. Want to see how this looks in action? Check out the visualizations in the paper. They're like maps of the NLP universe, showing how ideas branch and grow. Thanks for watching.